When I got into 3D printing almost 10 years ago, the level of technology and capability and what you would get in a somewhat affordable desktop 3D printer is not even in the same atmosphere as what you can get today for the same price. And in this video today, I have purchased essentially what is, for this point in time, the 3D printer of my dreams. So I thought I'd share the experience with you guys and talk a little bit more about my background of how I got into 3D printing. So before I dive into showing you my dream 3D printer here, I just thought I'd quickly share my origin story with 3D printing. So how did I get into 3D printing? Well, it all started back in about the 2016-ish time frame when I was in undergraduate engineering studies at UC Irvine. And in my junior year, I started doing a lot of undergraduate research opportunity projects, getting involved in different kinds of studies and collecting data and building things and things like that. And one of my best friends at UC Irvine, and still to this day, said, hey, why don't you join this project I'm working on? We're using this really cool technology called 3D printing in a sustainable and kind of with a recycling kind of style mindset. And it was, at first I was like, I don't know, I want to stay in like renewable energy and wind energy, solar panels, stuff like that. And boy, I'm glad I made that decision to switch over to his project because I owe it to him. I'm still really good friends with him, one of my best friends to this day. Without him, I don't know where I'd be with 3D printing, if I'd be here today, both with my personal hobby at home and my full-time career in additive manufacturing and 3D printing as well. So I owe it to him for my start and my entry into 3D printing. And during that project that I joined at UC Irvine, that was my opportunity to cut my teeth with 3D printing. And the type of 3D printers that I was working with at that time, like I said in the intro to the video, are nowhere near, well, maybe the Ender 3s and the CR10 up here, but this guy right here, nowhere near the same level of technology of what I started with 3D printing. The 3D printer that I really cut my teeth on was something called a PrinterBot Simple, and then a PrinterBot Simple Metal. And I'll include some different videos and pictures of those printers just to kind of show you what I was working with. And we ran a print farm of 35 of these things, plus a few other different kinds of printers, to print a bunch of different cubes and shapes for this art technology project for a professor I was working under in this project. And so we were constantly running the print farm, turning over builds, fixing the printers, troubleshooting the printers. We had a whole bunch of spare parts. We had printers that we'd cannibalize for spare parts. I mean, we're only printing PLA, which is the most basic entry-level material you can get with 3D printing. No heated bed, no enclosure, just straight basic printer with a bed that moved left and right, a head that moved up and down, and forward and back, basically. So, you know, it's crazy of where things start at. And those printers at the time were about $500 to $600, and that was the cheaper side. Then there's other printers, like there was a Dremel, like the Dremel tool, they had their own 3D printer, that was closer to $1,000. And then there were like even printers made from laser cut pieces of wood. And that kind of all stemmed from that RepRap project of like the idea that a rapid replicator or replicating rapid prototyping machine that could build most of the parts it needed to construct itself, so to speak. And so that's where like the whole desktop 3D printing industry came from. And then there's the whole industrial side of 3D printing, which is, similar in the way the technology grew, but desktop printing has for sure seen some rapid growth over the past 10 years. It is absolutely crazy. So that's my origin story, and then throughout grad school I got more involved with 3D printing and using it in different applications with different materials like conductive polymers with graphene infused in the polymer. And then at my first job working in the aerospace industry, doing all types of jigs and fixtures and leading into parts that actually fly in the aircraft, which is what I do for my current full-time job today. So it's really cool to see the evolution of this technology and how much more readily available and affordable and scalable the desktop side of the printing house has become, in addition to the industrial side of 3D printing, or what's more commonly called for industrial 3D printing is additive manufacturing. That just kind of means that it has a little bit more maturity to it, control, higher temperature, higher grade, materials, things like that and of that sort. And those printers are what I work with for my full-time job every day. And so it's pretty mind-boggling that this technology is affordable and available for me to have in my garage to make parts reliably, not just trying to, there's another guy, I think Superfast Matt is his YouTube channel. He posted a video just this week on it's time to put a 3D printer in your garage, and I couldn't agree with him more, because 3D printers in the past were so notorious for being basically their own hobby. You had to like 3D printing to be able to use them. It wasn't a tool just like a set of ratchet wrenches or sockets and wrenches are. It was a 3D print, it was a hobby that if you did it well, then it would be a tool. But if you didn't have any interest in tuning and adjusting your printer, it was really no use, and a lot of people didn't have interest in it, and you really had to be, like Superfast Matt said in his video, a 3D printing nerd to actually, make parts somewhat decently. And 10 years ago, the materials, even for desktop printing, were not nearly what they are today. I mean, now with desktop printers, you can print carbon fiber reinforced polymers, you can print fiberglass reinforced polymers, you can print, basically metal almost. They have kind of like a wax polymer binder infused metal print filament that you can get and print with specialized hardware. It's mind-boggling. So now, especially with this printer, which I'll get to in a second here, it basically enables you to just buy it, have it ready to go out of the box, and then use it for whatever end use means that is you need it for. Whether it's like, for me, it's building parts and making parts for my C5 Corvette build, or like your go-kart build, or let's say you're really into RC planes. I've seen people print entire RC planes from these 3D printers. I mean, the sky's the limit with a desktop printer that is reliable, and that's truly where machines like this one are at. What I kind of equate this printer to is what the iPhone did to the smartphone industry back in 2007. So you guys remember 2007, Steve Jobs had their Apple annual press conference, and then they launched the iPhone. And man, did that shake up the tech world and the cell phone world, because at the time, before then, you were cool if you had a BlackBerry, a Palm Pilot. Then the iPhone came around and shook up the whole industry. And maybe it's not that extreme for this 3D printer, but I'd say this thing has gotten so much traction in the desktop and even, engineering consumer world as well, industrial world to some degree, that it's really forced other companies to step up their game and innovate, which I think is great. It just further progresses innovation, it drives competition. So it's really cool to see stuff like this, especially for the price point. Alright guys, so this is back in the summertime when I bought this printer during a sale that BambuLabs had on their website. So I didn't refer to it specifically in my intro, but of course, as many of you could probably see, or maybe for those that don't know too much about the desktop printing world, I went ahead and jumped on the bandwagon, rightfully so, and got myself a BambuLab X1 Carbon Core XY 3D printer. If you know anything about desktop 3D printers, I'll be preaching to the choir on this one, but for those people that don't know much about BambuLab as a company and the printers that they offer, starting, I believe, at the end of 2022, if I'm not mistaken, started from a Kickstarter campaign. They have taken the desktop 3D printing and really just the whole 3D printing, FDM, hobbyist and industrial market by storm. They have really created a product that is truly out of the box, ready to go, and just a good quality product. And for the longest time, as I mentioned earlier in the video, to get into 3D printing, you really had to know and want to tinker, know how and want to tinker with your 3D printer to get it to print well before you could actually use it as a tool in your garage arsenal of, fabrication tools, just like you would a welder or a chop saw to metal fabricate different components. You'd have to really tinker with the printer before you could actually use it to print stuff. But that is not the case with this printer. It is truly out of the box, ready to go. I've used these 3 different labs at my work. And a few of my friends have had them and coworkers, and I finally I was gawking at wanting to buy one of these for the longest time, and I saved enough pennies together to actually purchase one of my own, and I've been using it for about 4 months now, and this thing has been proving its weight in gold as far as capabilities go and just ease of printing. It is just astounding at how good this thing prints. So I'm just kind of walking through the process of unboxing this thing with you guys. It is boxed really well, packaged really nicely, and the instructions and how to set this thing up were all really well laid out. And I am in no way, shape, or form sponsored by BambuLabs. To make this video, I bought this completely with my own money, and so this is completely my own honest opinion without any sponsorship bias at all. This is just from my point of view as a heavy user of not just desktop 3D printers but industrial 3D printers at my full-time job. So just walking through the process of getting this all unwrapped, getting it set up. It's kind of funny. The smell of unboxing this thing reminded me of when you would buy a new PlayStation or Xbox, and it just kind of feels like a good quality consumer electronics product, basically. And so I've just been super stoked to get one of these in my hands. So you can see I logged into my Additive account to get it all set up. And like I said earlier, this thing is basically like the Apple iPhone of the desktop 3D printing world. It has just taken the market by storm and really made this technology accessible to so many people that either didn't understand super well or would just get frustrated or didn't have the time or patience, to try and troubleshoot other kind of less capable and mature printers. So got this thing out of the box, got it all plugged in, all the packaging and protective packaging removed. There was a lot of protective packaging that kept things from moving around during shipping, which is great. And it's amazing that they were able to ship this in such a small box and fit the whole filament AMS system within the printer to make it that much more compact during shipping. So I've got it all plugged in now, logged into my account. So now I'm going through a series of calibration tests during the setup process. So I can't speak to the exact inner workings of how this works, but the printer basically does a series of different frequency vibrations, and it's going to tune, I think, the feedback in the stepper motors or something of that sort. This printer does have basically a vibration. It's software and a capability to account for vibration due to the high print speeds that it's capable of. So I think that's what this kind of vibration test is tuning, so that it gets the proper feedback to account for that vibration during high-speed printing. One of the cool things that this printer offers is a LiDAR sensor that you can see hanging off the right side of the printer head. That LiDAR sensor will scan the first either there's a kind of extrusion pass that it does for calibration, and then it'll scan the entire first layer to see if it needs to adjust that the extrusion rate or flow or bed leveling, depending on the thickness and quality of the extrusion. That is something that I have not seen on any other printer, desktop or industrial printer, and especially a desktop printer for the price point. I mean, $1,500. This one was a little less because I got it on sale. You just can't beat that. It's unheard of. So it's really cool to see where BambuLab has taken this technology and how much they really have forced the desktop, hobbyist, and industrial 3D printing world to rapidly innovate and adapt or fall behind, basically. So I'm still going through all the different tuning processes. So now it's tuning a different kind feature on the printer. Don't know exactly what. If you guys know exactly what it's doing during this calibration step, I'm assuming it's tuning some type of feedback, resonant feedback and frequency, and just, you know, because it does these circular passes at different speeds and diameters. So what this printer has really allowed me to do, so now that the calibration is complete, I can start getting close to my first build file on this machine. But what this printer has really allowed me to do is just really just focus on designing parts and then prototyping and rapidly iterating a design without having to worry about the printer failing or having an issue during that process. I can really just truly trust that this machine is going to do what I want it to do. I'm going to put a part in the build plate, or put a part in the slicer software. I'm going to send it to the printer wirelessly, which is great, from the slicer Bamboo app that they have, and then however many hours later I can just really trust that this thing is going to print well, and it's going to print the part that I need to do the function for either end use or a fit check, a prototype, a mock-up, you know, things of that sort. And on top of that, I'm not just printing PLA. So for those that don't know, PLA, polylactic acid, is the most basic form of polymer that you can use in extrusion-based additive manufacturing or 3D printing. It's a great material, actually has a pretty relatively high tensile strength compared to a lot of other commodity and desktop consumer polymers, but what it fails pretty hard at is temperature resistance. If you leave PLA parts in your car on a relatively hot day, even if it's just 85, 90 degrees out, the car is going to be about 10, 15 degrees hotter on the inside. Those parts will warp beyond belief. So, with that being said, I really can't focus on just printing PLA, even though that's what I'm doing right now in the video. Is I'm just kind of going through, and I'm going to select, of course, the 3D Benchy like you do as a first calibration print. I'm printing PLA in this video, but end goal, because I'm going to be focusing so much on automotive parts that either need to withstand either a lot of relatively high heat, you're not dealing with like exhaust temperatures, but relatively high heat and long-term exposure to UV. So that means I'm going to be printing a lot of ASA, which is acrylonitrile styrene acrylate, which is a cousin to ABS, which is kind of really the second most commodity plastic. ASA has a little bit nicer features, a little bit easier to print with, has a little bit more ductility, less likely to crack and delaminate during printing, and it's got way better UV resistance than ABS. So if you're printing automotive parts, it's pretty much a go-to to use ASA for your printer. But that stuff still can be notoriously difficult to print with on a standard printer, because you got to get it hot enough, you got to print with an enclosure, which thankfully this printer, due to its build construction, is already enclosed. But still, it can be a relatively hard material to print with due to warping, you know, pore layer adhesion and layer delamination, things like that. But this printer, I tell you, I got a sample spool from a coworker of mine, and it was 3-year-old filament that I dried one time for 12 hours, and I left that in the printer over the course of a month as I exhausted the spool, and this thing printed it beautifully. So you can see here what it's doing right now is it's actually calibrating the LiDAR sensor. It's got kind of like a QR code on the right side of the build platform there, so it scans that for its initial calibration. And then what it's going to do before the build starts is actually lay down a few strips of, well, right now it's actually performing the auto bed offset calibration. It's not bed leveling, it's offset calibration. So it's basically probing and sensing all the different points. I think it's 25 points across the bed, and then it comes up with a compensation value based on what its deviation is, either above or below the nominal Z value. So it's not bed leveling, because you're theoretically not doing any mechanical leveling to the printer or the bed itself. So you can see in the front there, those are all those extrusion strips that the printer lays down and then scans with the LiDAR sensor before beginning the build to calibrate the extrusion and flow rate. But what I was getting to before was this thing, this printer just prints ASA, which is a relatively easy but also challenging material to print with all at the same time. It just prints it so nice and easy. I've only had a few minor issues with really just warping due to poor adhesion to the bed, but I haven't done any adhesion promoters aside from just the PEI flexible sheet itself. Haven't put any glue or tape or anything. So it's been really reliable as far as printing ASA on this configuration. And I just love the Bamboo Handy app where you can start builds, track builds, watch builds, all from your smartphone. You could be halfway across the world and you could watch your printer be printing, which is just mind-boggling for the price point of this machine. So of course, as you do with any initial printer setup and calibration, you got to run a 3D Benchy boat. So this is what I'm doing for this print here. Is it was preloaded using for PLA material, so I was like, oh, I'll just kind of load this up and get it going real quick here. So it's a nice Benchy to add to the collection, and this time in a green color because I don't have a green one yet. But it's just really cool to have that feature baked into your phone. You can see the status, you can stop the build, pause the build if you notice any issues, and just see the overall status of the printer, which is just so cool for the price point that you get with this machine. But this machine I'm just so excited to use for all the automotive applications. It's really going to allow me to rapidly iterate and design and come up with new parts that much faster. I still love my other 3D printers, my Creality Ender 3s and my CR10. Those will never go away. Those hold a special place in my heart because they're my first printers and they are open source and they allow for a lot more tinkering and kind of customization and modifications versus this machine is kind of a little bit more. I know people customize these things, but I'm going to be less inclined to do that, to just kind of keep this focus as a production machine and maybe do a few minor mods that are common to improve things, but I haven't really found the need for that yet, even after using this thing for 4 months. So this is just another test print. This is like a pen desk organizer thing. It's also preloaded, so I had this spool of green PLA that came with the printer, so I just thought I'd exhaust this. So now I got the printer set up in my enclosure. It fits really nicely in there. Really don't need an enclosure because it's an enclosure within an enclosure, but hey, all the more help that you can get for printing temperature sensitive materials, I think is a win. So just really cool setup. The quality of materials, the quality of the build is just on a whole new level. Like I said, I love my Crealities, but this thing is just has stepped it up a notch. So on top of, once I got the PLA kind of exhausted, I moved to that ASA and started with printing a ton of different calibration parts. So this is kind of like a generic stress test. You can get this on Thingiverse. It tests overhangs, it tests small features, circular features, square features, bridging, little cylindrical pegs, a bunch of different features. So I was really, and then this is a ruler that tests horizontal holes, vertical holes, and then just overall extrusion. I was really testing to see what the optimal percent is for the duty cycle for the cooling fan. And for the part cooling fan, and I found that running the part cooling fan no more than 20% throughout the entire build really gave me the best success. Anything less than that, you kind of saw the part wouldn't cool fast enough, which is what happened on, I think it was the right one there, the less clean version. Anything more than 20%, you were risking not having the previous layers be warm enough for good layer adhesion. The next print I printed was just a mouse. It was actually a file with all the electronics that I got in the printer itself. So that was pretty cool. And then I printed a 3D Benchy out of ASA also. So I had a black one to go with my green PLA one. But, you know, guys, that's going to do it for this video. I hope you guys enjoyed it. I just want to share my experience with basically buying what it was like buying the iPhone of desktop 3D printers. This thing's on a whole new level. If you're interested at all in getting into 3D printing, this is a huge recommendation of mine. I have recommendations for different people for different reasons for these printers here, the Ender 3s, so they're still very relevant in today's 3D printing market, but BambuLab is a really cool machine. So I'm excited to use this thing for, again, making all different kinds of parts for my vet build and just other projects that I'll showcase on the channel. So I hope you guys enjoyed this one. Come back for more videos. I'll be doing a lot more 3D printing content just after I'm done wrapping up filming this video. I'm going to be doing some filming for another product that I'll be dropping soon on my Etsy store and YouTube channel. So thanks again, guys, so much for watching. If you haven't already, subscribe for more videos on the channel. And other than that, I will see you guys in the next one.